Okay, so now we are up to section 9.4, which is about internal rate of return, which is another very important alternative for evaluating capital budgeting decisions. And I just fair warning, this section has some fairly technical and complicated concepts in it that you are going to be required to know about for the concept check homework. So, you might need to listen to this twice. You might need to read the book on top of listening to me. You might need to do some Googling if it still doesn't make sense, but you'll get there, okay? So the internal rate of return, from a most simple perspective, is the point at which the net present value is zero. Right? So if you think about a net present value is the discounted cash flow discounted at the cost of capital, right? If you discount your cash flow to the point where the net present value is zero, what that means is that's your return on your investment, right? That's essentially your interest rate, right? And so, it's a pretty straightforward concept. In the days before computers, it was very complicated to calculate this. You had to kind of make a guess and then just keep guessing closer and closer and closer, solving for zero here. Okay, and we are not going to do this by hand, I can assure you. And so your book spells it out for you. You calculate the IRR of an investment, and then if it's greater than your hurdle rate, your discount rate, your cost of capital, whatever you want to use for this idea, but one of the commonly used terms for the required rate of return is the hurdle rate, because if your IRR clears it, then you can go ahead and go forward with the project. Okay. Now, it's important to note that the hurdle rate should reflect the proper level of risk for a project. So I discussed that, or I mentioned it anyways, when talking about venture capital and early stage investments. They require a very high rate of return because early stage investments are very risky. And as your book goes on to say, companies will actually post their hurdle rates, which a project needs to clear before the funding for an investment can go forward. And so the book goes on to discuss the relationship between NPV and IRR and what's called a net present value profile. And a net present value profile is the project's NPV at different discount rates. And if you look at a graph, which is below, right? So here's our copier project, right? At a discount rate of 0, our net present value is $7,500. At a discount rate of 41%, our net present value is 0. Right? And so, generally as the discount rate goes up, or as the hurdle rate goes up, the net present value goes down up to the point where your net present value is 0, and that gives you your internal rate of return. Now, normally I skip through these little sidebar stories here, but I want to just sort of note this one, right? A lot of you guys are interested in marketing as a field and are just taking these finance and accounting courses because they're required, and you need to do this stuff. But I can tell you, right, the highest salaries in the field of sales and marketing go to those responsible for selling capital equipment. If what you're selling is somebody else's capital budgeting decision, you can make some serious money doing that. If you're selling, and they give some examples, if you're selling enterprise software, dump trucks, copy machines, airplanes, it's important to recognize that your product is your customer's capital budgeting decisions. And so, even if you have no intention of going into finance, if you want to make some serious money in marketing, understanding how to speak to people about capital budgeting decisions will serve you well. Okay? All right, so the chapter goes on to discuss problems with the internal rate of return. So one of the problems that arises with IRR is arises because some investments don't have what's called a standard cash flow profile. In order to calculate an IRR with confidence, you have to have a negative cash flow in the beginning and positive cash flows in subsequent periods. But not all investments are like that. For instance, we have an example here of an investment that involves $11,000 upfront cost, and then some payments for a few years, and then a balloon payment, a negative cash flow of $20,000 at the end of year 5. So the thing is, because if there's no what they call a closed form solution to this problem, if you sat down and solved this algebraically, you'd wind up with 2 answers. Okay, one is 5.62 and one is 27.78. So a second problem with the internal rate of return is that it implies that you are constantly reinvesting the cash that is thrown off by the project at that same rate of return. So if you have, remember back to our copier examples, one of them had an IRR of 40%, right? I believe it was project B here. But, is it realistic to think that you're going to be throwing all your cash into a 40% return project? No, not really. But then the reason that this becomes a problem, and we go through a little bit of detail about why this is a problem. Okay, so this is back to our copier example. And remember, a net present value profile looks at the different NPVs at your different discount rates. And so if your project has one project has a steeper net present value profile than another, they cross over, and that would be the discount rate at which both projects have the same NPV, right? And so if you look at what that means, right, on the left-hand side of the crossover rate, you see, project A looks more attractive. It's got a higher net present value. But on the right-hand side of the crossover rate, project B looks more attractive. It's got a higher net present value, right? It's further up above this 0 line. And then what that also means, though, right? Project A here, the blue project, has an IRR which is lower than the IRR of project B, right? So if we're up here, if our discount rate is somewhere where project A has a better net present value than project B, then the decision criteria is going to conflict with the IRR criteria, which shows that project B is more attractive. Okay? So, how do we get past that? Well, we can get past this, right, with what's called the modified internal rate of return, or MIRR. Because one of the issues with the IRR, with the internal rate of return, is that, again, as I said, it's assuming that you're reinvesting at the rate of return of that project. But that is probably not realistic, right? What it is probably more realistic is that we can reinvest any cash inflow from this project at the cost of capital for the company. Right, so that is what the assumption is underneath the modified internal rate of return. Okay, and they take you through an example of how it actually works, but I can envision your heads just absolutely spinning. So what I would suggest is that you just keep that in mind as you go forward into the quantitative homework, and as you do it, it should kind of make these concepts make more sense, and then we come down to the ending of this, which is the question of which one is better, the modified or the straight IRR? Some people would say that the modified IRR is an improvement because the reinvestment rate is more realistic, but others would say that it's not actually internal, right? It's not internal to the project. It's not an internal rate of IRR because it depends on an external reinvestment rate. So, your book says we support using the NPV model. My finance professors during my MBA program said we support using the NPV model. In the real world, all the finance people that I have ever known have used a combination of IRR and return on investment. Return on investment is a little bit different from IRR because it does not look at the time value of money. So net present value is textbook and clear and clean and easy to calculate. IRR is widely used and it is part of the lingo of finance. And that's all we are going to do in Chapter 9. I'm now going to move on to Chapter 10 because, as you will notice, all this material in Chapter 9 assumes that we know what these cash flows are. But how do we know what the cash flows are? That's what's coming next.